Hello everyone. In this lecture we will see problems of rectification related to the loops. Let us read the problem. Find the length of the loop of the curve 3ay square equals to x into x minus a square. Let us see how to draw these loops on xy plane. So we have 3ay square equals to x into x minus a the whole square, that is the equation of a loop. First we will see that loop is present in between which two points and how to find out that. In LHS we have 3ay square, so we will put y equal to 0 in LHS. So for y equal to 0 we get equation as 0 equal to x into x minus a square. This implies the value of x is either 0 or x minus a the whole square is 0, which implies either x is 0 or x is equals to a. So clearly for y equal to 0 we are getting two values of x. So here we have 2 points. The first point is 0, 0 and another point is a, 0. So clearly the loop is present in between 0, 0 and a, 0. Suppose this is a, so the loop is in this way. So this is the diagram. It is just fish shaped diagram, just like this, either like this or like this. So we need to just see that where will be the tail of this loop. So for that we have to just see that either on the left hand side of the loop or on the right hand side of the loop this tail is present. So how to check that either the curve exists on the left hand side or right hand side. So here we can see that the left hand side of this loop is basically x less than 0 and the right hand side of this loop is basically x is greater than a. So we will see that either the curve exists for x less than 0 or x greater than a. We have the equation again 3ay square equal to x into x minus a square. Out of that this x is a non-square term, x minus a square is a square term, this y square is also a square term. So if x is less than 0, that is x is negative, in this case what will happen, we will get 3ay square is equals to, this is a negative number, and x minus a square. If I take x as a negative number, but negative number minus a, whatever is the number, either it is a positive or negative, square of that it always turn out to be positive. So in this case we will get 3ay square is equals to some negative answer. So 3ay square is equals to negative answer, which is contradiction. It is just because y square is always positive and 3a is a positive, so obviously the complete answer of 3ay square has to be positive always. Therefore curve does not exist when x is less than 0. And if I take any number greater than a, x minus a square will be always a positive term. This x is positive because it is greater than a, which is a positive side. So we will get 3ay square equal to some positive number. So obviously curve exists on the right hand side. So here we will have the tail of this loop. Now let us find out the arc length of this loop. So suppose this is O and this point is A and the point A is A, 0. Here we are going to find out arc length of this complete loop. Clearly this loop is symmetric along x-axis. So instead of finding the arc length of complete loop, we will just find out arc length of the upper half of the loop. Then twice of the arc length of upper half is the arc length of full loop. So S is equals to arc length of loop, that is same as 2 into arc length of upper half of loop, and that is same as 2 into arc length OA. Now let us apply the formula to find out the arc length. Before that let us see what is the given equation. So the given equation is 3ay square equal to x into x minus a square. Now in this equation it is easy to write down the equation as a function of x, or we can say that it is easy to take a derivative of y with respect to x. So just because of that we will use a formula of a rectification where we have dy by dx in the formula. So the formula that we are going to apply is twice integration square root of 1 plus dy by dx the whole square dx. And here we are going to write down the limits of x, x1 to x2. Now let us try to find out first what is dy by dx from the given equation of curve. So the given equation is 3ay square equals to x into x minus a square, differentiating with respect to x. So while differentiating this function with respect to x, we have to consider that y is a function of x And here I am not going to solve this x into x minus a the whole square. I'll just derivate this as it is using u into v rule. So let us apply u into v rule on x into x minus a square. U into v rule is u into v dash is equal to u into v dash plus v into u dash. So the differentiation of this equation 1 is 3a, derivative of y square is 2y dy by dx, because we are considering y as a function of x. Here we will apply u into v rule. So x into derivative of x minus a square is 2 into x minus a, and by chain rule again we have to take a derivative of x, which is 1, plus x minus a square, and the derivative of x is 1. Let us solve this. This will give us 6ay dy by dx equals to, here we can take x minus a common, and please try to solve this in this way only, because if you solve this bracket here itself and you will try to simplify it, then at the end you are not able to find out the integration properly. So please follow the same method for all problems of rectification where loops are involved. So x minus a, inside the bracket we will get 2 into x plus x minus a. After solving this we will get x minus a into 3x minus a. Therefore dy by dx is equal to x minus a 3x minus a divided by 6ay. We require in the formula 1 plus dy by dx the whole square. So let us try to find out that whole thing. So dy by dx the whole square is equals to x minus a square 3x minus a square upon 36a square y square. See, while substituting the value of dy by dx in this integration, we want everything as a function of x. But in our dy by dx, we have y here. So we are not replacing the y value here itself. See, after taking a square, automatically you will get y square at this place. So now here you can substitute the value of y square, which is x into x minus a square upon 3a from 1. So let us write down that. So from 1, y square is equals to x into x minus a square divided by 3a. Now I can substitute the value of y square in this. So we will get dy by dx the whole square equals to x minus a square 3x minus a the whole square divided by 36a square, and the y square is x into x minus a square divided by 3a. This a get cancelled out, x minus a square get cancelled out, and here I'll get 12. This is equal to 3x minus a square divided by 12ax. So now let us find out 1 plus dy by dx the whole square is equal to 1 plus 3x minus a square divided by 12ax. So let us solve this by cross multiplying. We'll get 12ax. Solve this bracket 3x minus a the whole square completely. We will get 9x square minus 2 into 3x into a, that is 6xa plus a square whole divided by 12ax. So this is equal to 9x square, 12ax minus 6ax is plus 6ax plus a square divided by 12ax. Now we can see that, see here, 9x square minus 6xa plus a square is 3x minus a the whole square. So 9x square plus 6ax plus a square is nothing but 3x plus a the whole square divided by 12ax. So generally whenever we are solving problems of loop, you will get 1 plus dy by dx square in this format only. Square of some term upon some denominator. Let us find out a square root of this. So square root of 1 plus dy by dx the whole square, this is equal to 3x plus a, that is the square root of 3x plus a square, and square root of 12ax, which we can also write as 3x plus a divided by root 12a into root of x. Then let us substitute everything in the formula. So we have the formula s as, let us see the formula first. So s is equals to twice x1 to x2 square root of 1 plus dy dx the whole square dx. So we know that s is equals to twice integration x1 to x2 square root of 1 plus dy by dx square dx. This is equal to 2 into integration of the square root term is nothing but 3x plus a divided by root 12a into root x dx, as we are writing here x. So meaning of that, we should write here the limits of x. Let us see the limits of x from the graph. So this is the graph. We are finding the arc length of the upper half of this loop, that is arc length OA. We have to just see the end points of this arc length OA, that is O and A. So coordinates of O as 0, 0 and coordinates of A as A, 0. We just need x coordinates, so that means we need 0 and A. So the limits of the integration are 0 to A. So this is equals to 2 square root of 12 a, that is constant. Out of that square root 12, I can write it as 2 root 3 into root a. Integration 0 to a. We'll have here 3x plus a upon root x dx. Then this 2 get cancelled out and we will get here the value as 1 upon root 3 into root a. Integration 0 to a. Let us separate the numerator here. So we will get 3x upon root x plus a upon root x dx. So this is equal to 1 upon square root of 3 into square root of a. This is integration 0 to a. 3 into, let us write down the power of x here. The power of x is x raised to 1 minus half, that will be x raised to half, and here clearly it is x raised to minus half dx. Now we can easily integrate this using the formula. The formula that we are going to use over here is integration x raised to n dx is x raised to n plus 1 upon n plus 1 plus c. So using this formula, we will get the value over here, root 3 into root a, 3 into x raised to half plus 1, that is nothing but 3 by 2 upon 3 by 2 plus a into x raised to minus half plus 1 is nothing but half. So x raised to half upon half, and the limits that we need to substitute are 0 to a. So this is equal to 1 upon root 3 into root a. Let us substitute over here the value a. This 2 will come up, so it will be 2 into 3, a raised to 3 by 2 upon 3. This 3 get cancelled out, plus here it is a into a raised to half. This 2 will come up, so it will be into 2. If I substitute 0 here in x, I'll get 0 in both the terms. We will get from this is 1 upon root 3 into root a. This is 2 into a raised to 3 by 2 plus a raised to 1 into a raised to half is nothing but a raised to 1 plus half, which is 3 by 2 into 2. So we will get the answer as 1 upon root 3 root a, and this is 4a raised to 3 by 2. This is equal to 1 upon root 3, and root a is nothing but a raised to half, which will come in the numerator and it will become a raised to 3 by 2 minus half. So we will get the final answer as 4a raised to 3 by 2 minus 1 by 2 is nothing but a raised to 2 by 2, that is a raised to 1. So 4a upon root 3 is the final answer. Let us see the another question. Show that the length of the loop of the curve 9ay square equal to x minus 2a into x minus 5a square is 4 root 3a. First we will see that this loop is present in between which 2 points. We will put y equal to 0 in the left hand side because we have only 9ay square term in the left hand side. So put y equal to 0, which imply 0 equal to x minus 2a into x minus 5a square. This will give us x is equal to 2a or x is equals to 5a. So here we have 2 points. First point is 2a comma 0 and another point is 5a comma 0. So clearly loop is present between 2a comma 0 and 5a comma 0. So consider here we have 2a and here we have 5a. So this is 2a, this is 5a, and the loop is present in between this. So this is the loop that we will have. Now we need to see that where is the tail of the loop or curve exists on which side, either on left hand side or the right hand side of the loop. For that we will consider the equation which is given to us, that is 9ay square equal to x minus 2a x minus 5a square. Again, we can see that this y square is a square term, x minus 5a square is a square term, only x minus 2a is not a square term. So that means if I take any number less than 2a, any number less than 2a means we are on the left hand side of the loop. If I consider any number less than 2a, so that implies x minus 2a is less than 0. Less than 0 means that number is negative. So that implies x minus 2a is negative number. So if x minus 2a is negative number, then let us see what will happen with the equation. I have 9ay square. In that, x minus 2a is a negative term. So this is negative term. X minus 5a the whole square. Now this is a square term. So either this x minus 5a is a positive number or a negative number. As I am taking a square of this, it is always turn out to be positive. So we will always get a positive number over here for x minus 5a square. This 9a is a positive term. So clearly we can say that we are getting here y square is equals to some negative number. So y square is negative is not possible because y square is always a positive term. So this is contradiction. So we can say that which is contradiction. That implies curve does not exist when x is less than 2a. So clearly if curve does not exist on this side, then the tail of the loop is on other side. That will be somewhere over here. Clearly curve exists on right hand side whenever x is greater than 5a, because whenever x is greater than 5a, anyhow x minus 2a will be always positive, x minus 5a square is always positive, therefore y square is positive. So definitely curve exists whenever x is greater than 5a. So this is the way we can draw the curve. Now we need to find out the length of the loop. Write down this as A and this point as B. So as we need to find out a complete length of the loop, but we can see one thing, that loop is symmetric along x-axis. Hence, we can just find out the arc length of the upper half of the loop, that is arc length of AB. Here in this case, S is nothing but length of the loop, which is same as 2 into arc length of upper half of loop, which is equal to 2 into arc length of AB. Now let us see the equation of the curve. 9ay square equals to x minus 2a into x minus 5a square. Depending on the equation, we are going to choose our formula of rectification. So here obviously it is easy to find out a derivative of y with respect to x. That is, we are going to consider y as a function of x. So let us use the formula of a rectification in which we have dy by dx. So this is same as twice integration square root of 1 plus dy by dx. So here we are going to integrate obviously with respect to x. So we are going to write down the limits from x1 to x2. That is limit of x. So first let us find out what is dy by dx. So we have 9ay square equal to x minus 2a into x minus 5a the whole square. Let us call this as 1. So differentiating this with respect to x, we get 9a, derivative of y square is 2 into y dy by dx is equal to, again for x minus 2a into x minus 5a square. So I'm going to use u into v rule to find out the derivative. So this is x minus 2a, derivative of x minus 5a square is 2 into x minus 5a, and the derivative of x minus 5a is 1 using chain rule, plus x minus 5a square, and the derivative of x minus 2a is 1 minus 0, that is nothing but 1. Then so this is 18ay dy by dx, and here I'm not going to solve the bracket x minus 5a square. Instead I'm going to take common term outside. So x minus 5a is common. So the remaining terms are 2 into x minus 2a plus x minus 5a. So this is equal to x minus 5a multiplied by 2x minus 4a plus x minus 5a. And after solving this, we will get x minus 5a into 3x minus 9a. I can take 3 also common from this bracket. So we will get 3 into x minus 5a into x minus 3a. And here we have 18ay dy by dx. So we will get dy by dx is equal to x minus 5a into x minus 3a divided by 6ay. Clearly in the integration, we are integrating the function with respect to x, so we don't want any y term in our function. But here I am not going to substitute the value of y because in the integration, I require dy by dx the whole square also. So instead of substituting the value of y here itself, first I take dy by dx the whole square and then I am going to substitute the value of y square. So this is x minus 5a the whole square, x minus 3a square divided by 36a square y square. So from 1, the value of y square is x minus 2a into x minus 5a square upon 9a. Let us substitute that over here. So let us first write down the value from 1. Y square is equals to x minus 2a into x minus 5a square upon 9a. So therefore dy by dx the whole square is nothing but x minus 5a square into x minus 3a square divided by 36a square, and the y square is x minus 2a into x minus 5a square divided by 9a. So this a get cancelled out, this is 4, x minus 5a square also get cancelled out, and the value of dy by dx square is x minus 3a square divided by 4a into x minus 2a. Let us find out what is 1 plus dy by dx square also. So this is equal to 1 plus x minus 3a square divided by 4a into x minus 2a. So this is equal to 4a into x minus 2a by cross multiplying, and let us solve x minus 3a square, which is x square minus 2 into x into 3, that is nothing but 6xa plus 3a whole square, that is 9a square divided by 4a into x minus 2a. So this is equal to 4a into x is 4ax minus 8a square plus x square minus 6xa plus 9a square whole divided by 4a into x minus 2a. So this will give us the answer as x square minus 2xa plus a square divided by 4a into x minus 2a. Clearly this x square minus 2xa plus a square is x minus a the whole square. You can see that x minus a the whole square is nothing but x square minus 2xa plus a square divided by 4a into x minus 2a. In formula, we require square root of 1 plus dy by dx the whole square. So this is equal to square root of x minus a square is simply x minus a square root of 4a into square root of x minus 2a. So this is nothing but x minus a upon 2 root a into root of x minus 2a. Let us substitute everything in the formula of s. So arc length s is nothing but twice integration x1 to x2 square root of 1 plus dy by dx the whole square dx, which is equal to 2 into integration square root of 1 plus dy by dx the whole square is x minus a upon 2 root a into root of x minus 2a dx. And the limits of x that we need to write it down, which we will write down from the diagram. So here in the diagram, coordinates of a are 2a comma 0 and coordinates of b are 5a comma 0. Here we require just the end points, that is a and b, because we are finding arc length AB here, and we required x coordinate because we required x limits. Those are nothing but 2a and 5a. So hence here in the integration x is varying from 2a to 5a. So this is equal to 2 into 2 by root a is constant, 2 get cancelled out, 2a to 5a x minus a divided by square root of x minus 2a dx. This integration we cannot solve because we have here a square root of x minus 2a in the denominator, which we are not able to separate it out. So here we require substitution. So let us use a substitution to solve this. So I'm going to put here x minus 2a is equal to t, which implies x is equal to 2a plus t, which will give us dx is equals to dt. Derivative of 2a is 0, so dx will be dt. As we have changed x by t, obviously we need to change the limits as well. So as x is varying from 2a to 5a and the value of t is x minus 2a, therefore t is varying from. So whenever x is 2a, 2a minus 2a is 0, so t is 0. Whenever x is 5a, that is 5a minus 2a is 3a, that means t is 3a. So the above integration s is equal to 1 upon square root of a integration 0 to 3a x minus a. Now the value of x is 2a plus t minus a divided by square root of t. Dx is nothing but dt. Now let us integrate this term. So this is 1 upon root a 0 to 3a. This is 2a minus a is a plus t divided by root t dt. So this is equal to 1 upon root a. Let us first separate the numerator and then we will integrate it. So it is nothing but a upon root t plus t upon root t dt. So this is equal to 1 upon root a integration 0 to 3a. A upon root t is nothing but a into t raised to minus half plus t upon root t, that is t raised to 1 minus half, that is nothing but t raised to half dt. So this is equal to 1 upon root a. Let us find out the integration just by using the simple formula of x raised to n. Integration of x raised to n is x raised to n plus 1 upon n plus 1. Let us use that. So it is a into t raised to minus half plus 1, that is t raised to half upon half plus t raised to half plus 1, that is 3t raised to 3 by 2 upon 3 by 2 with the limits as 0 to 3a. Now let us substitute the limits and find out the final answer. So 1 upon root a inside the bracket 2a 3a raised to half plus this is 3a raised to 3 by 2 into 2 by 3. If I substitute 0 here at the place of t, I'll get everything as 0. So this is 1 upon root a. This is 2 into root 3. This is a into a raised to half. That is nothing but a raised to 3 by 2 plus this is 3 raised to 3 by 2 upon 3 is nothing but minus 1. A raised to 3 by 2 into 2, which is equal to 1 upon root a. This is 2 root 3 a raised to 3 by 2 plus, so this is 3 raised to half a raised to 3 by 2 into 2. So this is equal to 1 upon root a 2 root 3 a raised to 3 by 2 plus 2 root 3 a raised to 3 by 2. So this is nothing but 1 upon root a 4 into root 3 a raised to 3 by 2, which is equal to 4 into root 3 a raised to 3 by 2 minus half, which will give us the final answer as 4 root 3 a raised to 2 by 2, that is a. So arc length of the loop is 4 root 3 a. Thank you.